Hello, and welcome back to Teacher Gimble's channel. Today I'm going to be going over the Illustrative Math, Algebra 1, Unit 1, Lesson 2. I skipped Lesson 1 because that's classroom introductions. I'm going to go over the practice, and I'm going to do these problems just like I would do them myself, and how I would show a class to do them. Let's jump in. Problem number 1. The dot plot displays the number of bushels in the yards for houses in a neighborhood. What is the median? The first thing I need to know for this question is, what is a median? The median is when you have a set of numbers. It represents the number that is exactly in the middle, where 50% of the numbers are below that value and 50% of the numbers are above that value. It's a lot easier to see with an example, so let's use this example here. Each dot in this dot plot represents a number. So that one dot here represents a 5. The second dot above represents another 5. These are both numbers of bushes in the yards. So we have 3 houses that each have 6 bushes, represented by those 3 dots. We have 4 houses that have 7 bushes, represented by those 4 dots, 3 with 8 bushes, 2 with 9 bushes, 1 with 10 bush, and then 5 with 11 bushes. So I put down 11 5 times, each of these 11 representing the house. Now, when I'm taking the median from a list of numbers like this, I like to say, I want the number somewhere in the middle, but to figure out exactly where it is, I just count by crossing them off on either side. So for each one I cross on, that 11 over there, this 6, this 6, this 7, this 10, this 7, this 9. And I go down till I reach the one in the middle. This is an 8. Now, if you didn't want to sit and write out all of the numbers in order, you can actually do the same thing with the dots. I cross out a 5 here, so I cross out an 11 over there. I cross out another 5, I cross out another 11. I cross out a 6, I cross out an 11. A second 6, a second 11. If doing it this way will also get you to that number in the middle. So the answer to that question is the median is 8. And that means half of the houses have less than 8 bushes and half the houses have more than 8 bushes. Let's move on to the next question. Feel free to pause at any time if you need a little bit more help or to go back over the beginning of this video. Problem 2. The data set represents the shoe size of 19 students in a 5th grade physical education class. This is our data over here. Create a box plot to represent the distribution of the data. So we need to know what a box plot is. So a box plot is a visual way to look at a spread of data. There are 5 values we need to know for a box plot. So I'm going to create a little table over here. The first value I'm going to want is what we just talked about, which is the median. So I'm going to put median here. We already know how to find that. So let's go ahead and cross out our values. I like to make sound effects while I do it. And if I make a mistake, please let me know in the comments. I do these videos like you would do them, the problems on your own. And everybody's liable to make mistakes. I made the median. Now I'm going to find my minimum, which is my lowest value. That's a 4, because 4 is my lowest value. Max, which is my highest value. That's a 9. And then the next thing I'm going to do is I'm going to underline my half a date on the left and half a date on the right. And I know I've got some things crossed out, but we can do this. This is my bottom 50% of data. This is my top 50% of data. I'm going to look for 2 values. We call them Q1 and Q3. All these are is finding the median the second time, just using the bottom half of data. So I'm going to cross out. I'm left with a 6 in the middle. That's going to be my Q1. I'm going to label it right here. I'm going to put this as median. I'm going to put here as min, and here is max. And then do the same thing on this side. If I cross out 1 at the bottom, I cross at the top. And I am left with 8 in the middle. I'm actually left with 2 8s in the middle. Let me go ahead. I think I counted wrong. So let's double check. I cross this, here, here, here. I'm left with 2 8s in the middle. And when I'm left with 2 middle values, all I do is I add them together and I divide by 2, which gets me 16 over 2, which gets me 8. I know my Q3 is 8. Now we're up to we did the hard part, now it's the easy part. I like making a number line. My number line is going to start with my lowest value, and I'm going to just count up to my highest value. Now here, My lowest and my highest value are pretty close, so I'm just counting by ones. But sometimes you might need to count by twos or fives or tens. I'm going to put a line on my lowest value, on my min. I'm going to put a line on my highest value, which is my max. I'm going to put a line on my median, a line on my Q1, and a line on my Q3. I'm now going to connect the middle lines. That creates my box, and then connect the min and the max, and that creates my whiskers. And there we go. We created our box and whisker plots using our data. Feel free to pause this video here if you need to spend a little bit more time thinking about this concept or review what we did to get there. Let's go on to the next question. Oh my goodness, there are a lot of graphs in this problem set. We got this. So, the data set below represents the number of pages in the last book read by each of 20 students over the summer. We have the set of data. Create a histogram to represent the distribution of the data. So the first thing I'm going to do is I'm going to situate myself with my data. Let's move my pen over so we have space here. I see that we start at 163 and we go up to 431. So I'm going to make my life easy and I'm going to make myself 4 bins. What are the bins, you ask me? Well, the bins basically is I'm going to stick my data into 4 separate categories. The first category is going to be 100 to 200. So those are any values between 100 and 200. The second bin will be from 201 to 300. And the third bin will be from 301 to 400. And the last bin will be from 401 to 500. Now, I chose 5 bins because I saw we spread from something in the 100s to something in the 400s. I'm now going to count how many values are in each bin. And don't mind my messy boxes. That's how math works. So between 100 and 200, I have 1, 2, 3, 4, 5 boxes. Then between 200 and 300, I have 1, 2, 3, 4, 5, 6, 7. Between 300 and 400, I have 1, 2, 3, 4, 5, 6. And between 400 and 500, I have 1 and 2. Now, these numbers represent the number of students who have read this many pages. So, for example, 2 students have read between 4 and 500. Now, for a histogram, you're on an axis. Down here, I'm just going to pop my bins. How many bins did I have? I had 1, 2, 3, 4, so I have 4 bins. This bin's going to represent 100 to 200. This bin, 201 to 300, 301 to 400, 401 to 500. Okay, now that I've made my bins, this over here, I'm going to label it and I'm going to put down pages read. I could put down pages read by students. Now here is going to be my counts. So let's think. Our lowest value is 2, so I'm just going to start with 1, 2, 3, 4, 5, 6, 7. Now, if I was doing this for a homework set, I would do it on a lined piece of paper, but I don't have that. I just made a mistake. So I saw 2 and I put it as a height of 2. That's not correct. Because in this case, the number of students that read between 100 and 200 pages, that's 5 students. So I'm going to draw a box of 5. The number that read between 201 and 300 was 7 students. That's why that box goes all the way up to 7 for 201 to 300. For 301 to 400 was 6 students. So my box goes right there. And then 401 to 500 was 2 students. So my box goes right over there. I don't need that little extra line. And there we go. We have our histogram. If you want to color it in, you can color it in. I like doing that. I feel like it makes it look more official, but you don't have to. And this is a second way of visually representing the data. Again, pause the video if you need more time to go over this concept. We are on to problem number 4. We are almost done. Each set of data was collected from surveys to answer statistical questions. Select all of the data that represents numerical data. Well, this guy's numbers, so he's numerical. Check. This guy is not numbers, not numerical. Numbers, numerical. This is numerical. I paused because negative numbers, are they always come out in real life, but you do have temperature, which would be -5 degrees, and that's still numerical data. Numerical data, no numbers, so not numerical data. Let's keep going. And we got F, this is no numbers, not numerical, no numbers, not numerical. That was an easy, quick question. Numerical just means, is it representing numbers? Now, problem number 5. What is a typical distance a moped can be driven on a single tank of gas? A statistical question. Explain your reasoning. So when I'm thinking of statistical questions, I like to think, is there more than one answer to the question? So this says a moped. If I ask that question to 5 different people and say, how far does your moped drive on a single tank of gas? Am I going to get the same answer every single time? No, I'm not. Sometimes it might be 20 miles, sometimes it might be 25 miles. It changes. So if the answer can change, that means that it is a valid statistical question. And the reason for it being a valid statistical question is just that. The typical distance a moped can be driven on a single tank of gas is a statistical question because the answer changes each time, or can change each time. All right. If you have any questions, please leave them in the comments below. And if you want any other lessons explained, also leave them in the comments below. But if you like this video, please like and subscribe and follow me for more math videos. Thanks for watching.